Hello everyone, this is Gautami. This is our second lecture for theory of failure. Today we'll be dealing with maximum shear stress theory. As I've already mentioned, you need to know the different names of the theory, its formula, and the graph, and for which material it is used. These are the important things. So maximum shear stress theory is also known as maximum stress difference theory, and it is also known as Tresca theory, and it is also known as Gates theory. So these are the four names given for this maximum shear stress theory. Maximum stress difference theory, Tresca theory, and Gates theory. So when it comes to the formulation, as the name suggests, they are telling it's a maximum shear stress theory. So it's a maximum shear stress, right? So from basic elasticity, we know the maximum shear stress is nothing but sigma 1 minus sigma 2 divided by 2, where your sigma 1 and sigma 2 are the principal stresses. Okay, so for a three-dimensional system, you will have all the three normal stresses, and if you have all the three normal stresses and your shear stresses, so the corresponding principal stresses will be sigma 1, sigma 2, and sigma 3. So the formulation for maximum shear stress theory would be, you need to select the maximum among sigma 1 minus sigma 2 divided by 2, or sigma 2 minus sigma 3 divided by 2, or sigma 3 minus sigma 1 divided by 2. So the maximum out of these three should be less than the tau y. This is the yield stress. So to predict where your structure fails, you need to know what is the maximum stress it can take. So for an aerospace engineer, failure is, in the sense, don't imagine like a disaster, aircraft is broken into pieces or something like that. No, it's not like that. For an aerospace engineer, a failure in the sense, the structure which you have intended to do some function will fail to do its function. For example, you have a airfoil. You have designed your airfoil for the smooth flow and to generate lift. So there is some deformation and your airfoil has changed its shape. So now, for what purpose you have designed this airfoil is not satisfied. This starts behaving in different way. So this is a failure for a aerospace engineer. So you need to look after this. So have to predict, you have to know the maximum stress, and this maximum stress should be less than your yielding stress. So this is the formula for your maximum shear stress theory. So this is the formula and different names for this theory, and this theory is well suited for your ductile materials, like your engineering materials like aluminium, cast iron, etc. So for ductile materials, we use maximum shear stress theory. So now let us consider a bar, and we'll apply load. Here sigma y is the yield stress which is acting on the bar. So now we know your maximum shear stress is equals to sigma 1 minus sigma 2 divided by 2. So in this bar, since there is only sigma y acting, so the corresponding principal stresses will become sigma 1 is equals to sigma y, sigma 2 is 0, sigma 3 is 0. So maximum shear stress is nothing but your yielding stress here. So sigma 1 is sigma y, sigma 2 is 0. So this tau y becomes sigma y by 2. So this is one more important formulation, that is tau y by sigma y is equals to 0.5. So block this formula, and this is very important because in most of the questions they give you sigma y and you need to calculate your tau y and use it in your formulation, because in your formula you have tau y. So if they give you sigma y, you need to convert it into tau y and then use it in the formula. Then this is one more formula. So when it comes to graph, your maximum shear stress theory has a hexagon shaped graph in this format. This is sigma y, this is minus sigma y plus sigma y. So this is the maximum stress, in the sense the yielding stress marked here, and the region within this block, within this envelope, this is the safe region for your structure. Your structure will not fail within this envelope. So once it crosses your yield stress, the structure may fail. So this is your job to calculate what is your yield stress, whether the maximum stress acting on your structure is less than your yield stress or more than your yield stress. If it is less, then your structure is safe. If it is more, then you need to redesign your structure. So this is the graph. Okay, one second. Okay, so we had marked, right, sigma tau y by sigma y equals to 0.5. That represents this line, equals to, this is 0.5. Okay, so to brief it, the important things we have discussed till now. The first thing is different names of the theory, then the formulation, then on what material you can use this theory, then the graph, and the fifth one is tau y by sigma y ratio. So these are the things very important. You need to revise, you need to learn, you need to understand these concepts. So this covers your maximum shear stress theory. I'll be continuing the second theory in my next lecture. So thank you. Share the video for people who are in the need, and like the video. Thanks for watching.